Welcome back. This is tutorial 8, question 6, exercise 27. We are given a square matrix A with these entries, and we are given three vectors v1, v2, and v3. And we are asked to show that these three vectors are eigenvectors of A. And remember that to show that something is an eigenvector, we'll just basically take the vector, for example v1, and we hope that it'll be some scalar version of v1. Alright, so what we're going to do is A, and then v1 is 0.3, 0.6, and 0.1. And then I will leave it to you to do this matrix vector multiplication. I'm going to use MATLAB to do it, and here's my answer. You have to do it by brute force. In MATLAB, I enter the matrix A, as you see here, and then I multiply with a vector 0.3, 0.6, 0.1 transpose, basically making this a column vector. So it's A times v1, and I get 0.3, 0.6, and 0.1, exactly the same. So what it means is that I have the eigenvalue equals to 1 for this eigenvector. So this is my answer. Basically, I write that A times this vector is equals to the same vector. Therefore, this vector v1 is an eigenvector associated with eigenvalue lambda equals to 1. You can do the rest, and I'm going to write for you here first, and then I'm going to write the answer for you. And then the result is that we know that all these three vectors are eigenvectors. Let me pause. So this side, I've multiplied A times 1 minus 3, 2. And the other one is A times minus 1, 0, 1. And we see that this is the answer, which is 0.5 minus 1.5, 1. And what we are seeing is that this is actually half times the original vector given to us. Therefore, lambda is equals to half for this eigenvector v2. What about the last one? In the last one, for v3, we get basically 1/5 of the original v3. Therefore, the eigenvalue is equals to 1/5 for this corresponding eigenvector. Now I'm going to show you how I do it using MATLAB. I use MATLAB as a simple calculator. So this is the matrix A, and to get the eigenvalue and the eigenvector, I'll use this command, EIG of A. EIG of A takes a matrix A and returns two matrices. P is the eigenvector and D is the eigenvalue. The eigenvalues are in the diagonal of D, which is 1, 0.2, and 0.5, as we have calculated just now. And if you compare that to the eigenvectors, 1 is for this eigenvector, 0.2 is for this eigenvector, and 0.5 is for this eigenvector. Now, it may appear to be very different from what we had in our text, but look at this more carefully. P1, if you compare P1 with V1, and you compare P2 with V3, and you compare P3 with V2, you will realize that P are normalized versions of V1, V2, and V3. The other clue that will give you which P belongs to is P1 corresponds to eigenvalue D1, P2 corresponds to this eigenvalue 0.2, and P3 corresponds to eigenvalue 0.5. That's another clue where we can associate with the original V1, V2, V3. So MATLAB produces eigenvectors that are normalized. The eigenvalues are in unsorted orders, so that may catch people off guard. So you have to study, or you have to examine the associated values in the diagonal matrix to extract the corresponding eigenvector. Thank you.